Okay, page 31. This section is a little longer. We'll try and attack it as fast as we can. A meter reader determines that business use this amount of energy, so I automatically call this energy, in 2 months. This is time. The cost of the energy is 10 cents per kilowatt. The minute I see a per kilowatt, I know that I'm not talking about cost, but I am talking about rate. And when it asks me to calculate the bill, they want me to go get the cost. So I know that is what I'm looking for. So cost equals, and then I look at my equations here. Sorry, this is French, but still. Cost equals rate times energy, okay? So rate times energy. Do I have rate? It's here, yes. Do I have energy? It's here, yes. And they're both in kilowatt hours. So this question is not too complicated. I just go ahead and I multiply, energy. Let's go back and fix this, sorry. 10 cents per kilowatt hour times my energy, 3,550 kilowatt hour. The kilowatt hours get eliminated because one's up and one's down. So it gives me a total of this amount of cents, or if you want to do it in dollars, you say $355. Okay, next up. Electric heater draws. This is my power. This is my rate. When it says cost, doesn't mean it gives you the cost. It just means the rate here. Operate 3 hours a day for 30 days. This is my time. So I do need to, before I start, I realize I got kilowatt hours and here I have watts. So I know I need to change this into kilowatts. So the first thing I'll do is I'll change my watt into kilowatts by dividing it by 1,000. That gives me 1.1 kilowatts. And my time I'll figure out in full hours. 3 hours a day for 30 days gives me 90 hours. So now I'm ready to calculate cost. This is what how much does it cost? They want cost here. So cost, like we set up here, is rate times energy. Now, they gave me the rate, but they did not give me the energy. So I gotta go figure out energy here. So I look at my formulas again. Energy is power times time. I do have power and time that I figured out here, so I'll just go right ahead and multiply my values. So 1.1 times 90 equals, I'm recording, 9.9 kilowatt hours. So now I have my energy and my rate. I can just go ahead and figure this one out like this. Kilowatt hours times 9.9 kilowatt, and that will give me my cost of 792 cents, or again, if you want to get it in dollars, $7.92. Okay, last two questions of the page. First, I got 750 watt toaster, 1200 watt electric frying pan. I put both together because they asked me the cost of the two together. So I know that this is P for both. They're plugged into the same outlet of voltage, 100 volts. So how much would it cost to operate if the rate is this? So this is my rate. They're obviously looking for the cost, and 3 hours is the time. So they want me to calculate cost again. Cost is energy times rate, or rate times energy, doesn't matter which one you pick. They've given me the rate over here. They have not given me the energy. So I will go over here and find out the energy first so that I can actually calculate the cost. Energy is P times T. Over here I got P all together and T over here. So let's just go calculate this. 750 plus 1200 equals 950 watts. I need it in kilowatts because the rate is in kilowatt hours. I have to divide by 1,000, and that gives me 1.95 kilowatts. which I then put in my formula. 1.595 kilowatts times 3 equals 5.85 kilowatt hours. So now I can put it in here. 5.85 kilowatt hours times 8 cents gives me 46.8 cents, or $0.486. Is that what I gave you guys in the answer sheet? Yes. Okay. Last question. 1 milliamp. This is current I, and it has to be in amps, so I know I have a conversion to make. Wattage, this is what we're asking, so we're looking for P, and we gave me the resistance. P is equal to I times V. I do have I here. I don't have V. It's not anywhere in here, which means I got to go find V, and if I take the formula for V, V is I times R. So if I multiply my current and my resistance, I'm going to get my voltage. First off, I got to take my 1 milliamp divided by 1,000 to get my amps. So this is 0.001 amps. And so 0.001 amps times 470 ohms will give me 0.470 volts. So this is my voltage. So now I got my current over here, my voltage over there. I have to multiply them. And yes, it gives me an extremely small value, and it is what it is. So, so this is my answer, and it's in watts. All right.